Okay, so this is try number 3 or 5, 6, 7, 10, thousandth time on getting number 18. But let me go back to the explanation when we were in the middle of this before I was interrupted by a couple phone calls. Here is the deal. On this, we use the fact that two tangent segments from the same exterior point are going to be congruent to each other. And we're going to use that all the way around. So we're going to start with what we know here. Like this one is 6 centimeters. So I know this one has to be 6 centimeters because they're the same from the same exterior point to the same circle. Well, if I use up 6 centimeters of a 12 centimeter segment, that leaves this one to be 6, which means that one's 6. So it's really easy to get there. And then I can do the same idea here. If this one's 7 centimeters, this segment had to be 7 centimeters. Well, the whole thing here is 17, so this leaves this one to be 10. Well, that means this one is 10 centimeters. Well, if I've used up 10 out of 15 centimeters, that leaves 5. So this would be 5. So this whole side is actually 11 centimeters. So your perimeter would be 12 plus 11 plus 15 plus 17, and remember that adds together to be 13, plus 13. So here I'm actually going to go backwards in my head. I know this is going to be 30, 45, 56, 12 more, 68 centimeters. Normally I don't go right to left, but just to add it real quick, it doesn't matter which order you add if you're only adding. And you get 68 centimeters. Now there's two other type of problems I want to talk to you about. One of them was 31, and on 31, I don't want you to really overthink this one, but you have these 3 different coins, and the coins are touching at a point each, and then we have this exterior point, and we draw these tangents in. Well, we know those two are the same because they're both touching this triangle, but I also know that if I look at that exterior point to this circle, they're the same, and by the fact of the transitive property, we can actually prove all 4 the same, and they're just using the idea if any 2 segments are from the same exterior point, tangent, from the exterior point, they're going to be congruent to each other. So that's the reasoning behind it. There's more reasoning, you have to write it down, but that's the concept behind it. And then the other one that throws a lot of people off is like number 33, but if you don't mark up your diagram, you have problems. And so make sure when you're stuck on something is you redraw it and mark it up. So here we have a circle, and they tell us AB is tangent to the circle, and then we have this diagram drawn like this. So we have A, O, B. This one over here is C. This is 4. They want you to know that one's 4. And then we have 1, 3, and 2. Now, a few things I want you to remember on this. They also tell you it's tangent, so you draw in right away our right angle, correct? And we also know the measure of angle 1 is 70 degrees. The one thing they didn't tell you, but you should know, is all the radii of a circle are congruent, which makes this an isosceles triangle. So those 2 angles are congruent to each other. So then I have to solve for the missing angle, which is angle 2 and 3. So you can literally just call it x. So you go 2x plus 70 is equal to 180. 2x is 110. X is 55 degrees. So I know angle 3 is 55 degrees. Well, 3 and 4 add up to 90. So the measure of angle 4 is just 90 minus 55. Well, that's 35 degrees. Well, hopefully that helps you also on a lesson 11.1. I know I didn't do every problem, but those should give you some good ideas on how to set them up. I was trying to think if there's any other ones that might be really beneficial for you. If you're struggling with number 20 or 22 or any of that, please go look at the ones where we used the Pythagorean theorem to solve for the missing sides. Hopefully this will help you guys with these problems.